జనరల్ 3 వరకైతే మన
Okay, so yesterday we have seen that we have defined in fact neighborhood of a point and epsilon neighborhood of a point, and we have seen that interior point and its applications. Today we like to define open set. There are so many definitions for open set according to our basic analysis. You take any subset of R is said to be open. Open set if and only each point is interior point. Each point of S is an interior point. Right, every point that you take, every point in inside S, that is an interior point of S. That happens, that is an open set. Suppose you take 1, 2, 3 simple set. Is it open?
No.
Suppose you start with this one. Start with this one. So is it interior point? We have seen that yesterday it's not interior point because we never find a neighborhood which is inside the set. We never find a neighborhood which is inside the set. So at least one point is not interior point means it's not an open set. Suppose you take this. Is it open? Yes.
Yes, sir.
You start with any point which is inside. Take any point. What is my definition? Take any point of S. I'm not interested in these points. I'm not interested in these points. What I'm interested is, just take a point which is inside S. Is it interior point? Yes. We find some neighborhood. It's inside the set. So therefore, every point that you take, you have seen that interior point of the set is. So therefore, it's an open set. Suppose you take this. Is it interior? Is it open set?
No, sir. 0 not
this. Yeah, you take this point, it's an interior point. You take this point, it's an interior point because we find some neighborhood. You take this point, it's an interior point because we find some neighborhood which is inside the set. But the thing is that we have seen yesterday, 0 is not interior point of the set. Why? Because this left side portion of 0 is not inside the set. Therefore, 0 is not interior point, therefore not open. It's not open in R. Why? Because 0 is not inside the set. 0 is for the 0, you never find a neighborhood which is inside the set. Therefore, 0 is not interior point of the set. Therefore, at least one point of the set is not interior point means that is not open set. Similarly, this is also not open set because 0 and 1 are not interior points. Take counting numbers, natural numbers. Is it open?
No, sir.
No, right? The same idea which works. So it's not interior point. 1 is not interior point, therefore not open. Take this. Is it open?
No, sir.
Right? Is it interior point 1? No, right? Which is not inside the set. Give me any neighborhood which is not inside the set. Therefore, 1 is not interior point. Therefore, not open. I'm not interested in other points because at least one point is not enough. Is not interior point of the set. It's enough. At least one point is not interior point is enough to show that something is not open set. As it is not open means you need to show that at least one point is not interior point. Here 1 is not interior point, therefore not open. Suppose you take 1 plus 1 by n. Is it open?
No, sir.
This is 2. This is 3 by 2. What is this? 3 means what? 4 by 3. Going on, going on, going on towards 1. So this point is not interior point. Therefore not open. Suppose you take this. Open 0, infinity. Is it open? It's a ray.
Yes, sir.
Right.
Yes, sir.
That's right. So you take any point. I find some neighborhood which is inside the set. It is an interior point. X is interior point. Similarly, Y also interior point. Because I find some neighborhood which is inside the set. So every point in S is an interior point. Hence it's an open. Hence it is open. Suppose you take close 0, open infinity. Is it open?
No, sir. 0 not
No,
in.
sir.
0 is not interior point. It fails to, find the neighborhood which is inside the set around 0. So therefore this portion is outside. This portion is outside. Therefore 0 is not interior point means we're not open.
Sir, small doubt, sir.
Tell me.
సార్ ఇక్కడ ఓపెన్ ఇంటర్వెల్ లో 0 ఇన్ఫినిటీ ఉన్నప్పుడు 0 ఇన్ఫినిటీ అందులో లేనట్టే కదా సార్ ఓపెన్.
Okay, it's not open. Okay. So collect all set. This is a definition. Collect all interior points. That is what interior of a set. What is interior of set? In some books it is defined by like a naught, like Rudin. In like Simmons, it is denoted by like this int of a. Int of a is nothing but what? Set of all interior points of a set. Yes. I'm taking S as a set. Interior of the set. You collect all interior points of the set. That is nothing but interior of S. What is interior of S? A set of all real numbers which is an interior point of. Okay. Suppose I'm going to start with some example. S is equals to open 0, 1. What is interior of a set? So collect all interior points. What are the interior points? Every point inside. This is interior point. Yes, we can find some neighborhood which is inside the set. Is it interior point? Yes. Is it interior point first? Yes. Is it interior point? Yes. So every point is interior point. Therefore, what is it interior point? No.
Yes,
Is it interior point? No.
Oh, no, sir.
So what are the interior points? Only set S. What are the interior points? Set S. Suppose you take close 0, open 1. You are asked to compute what is this interior of a set.
Open
Open
interval 0, comma.
Open
Yeah.
0, comma 1.
Is it 0 is interior point? First point. No. Is it interior point? Yes. Is it interior point? Yes. So every point is interior point except 0. Therefore, what is interior of set? Open 0, 1. So this is about interior of a set. This is about interior of a set. Interior of set is nothing but one set of all interior points of the set. And look at the properties. You take any subset of R. See, we are interested to work with R, the subsets of R only. I'm not interested in different metric spaces. What I'm interested in only R with respect to visual metric. I'm not interested in other metric because we're working with real analysis, not metric spaces. Okay, you take any subset of R. So first property is interior of a set is the largest open set. Is the open set in fact?
Yes, sir.
In fact, largest open set. You need to write it. Is the largest open set. This is contained in the set S. You give me any set, interior of A is the largest open subset of yes. Right? You give me interior of S is equals to S if and only if S is an open. something you want to show that this is very interesting property. Something you want to show that it's an open set. It's enough to show that interior set is itself. Here, look at this. Here, interior of a set is not S, therefore it's not open. Because interior of set is not S, because what is my S? Close 0, open 1. So interior of S is just after all 0, open 0, 1. After all open 0, 1. This is not same as your set. So therefore, this is not open set according to this property. Right? Third one is interior of A intersection B is equals to interior of A intersection interior of B. If A and B are subsets of R. Interior of A intersection B is equals to interior of A intersection interior of B. Of course, we can generalize this property to any finite intersection. A1, A2, AN is equals to what is this? This is equals to 1 to n interior of A. Therefore, interior of the intersection is equals to intersection of interior. This is what only for finite intersection. N is a fixed natural number. This idea may not, extend to infinite collection. This interior of arbitrary intersection means, in fact, countable intersection need not be equals to intersection of the interiors.
For example, -1 by n, comma 1 by n.
Yeah,
Open.
that's it. You take a set -1 I, or else you can take n notation. That is easy. You can comfortable because by real analysis. So you can take the notation an. Yesterday we have seen that. What you have seen?
Sir,
This is an open interval. This is an open interval. Therefore, every open interval is open set. We have seen just now. This is an open set. Whenever it is open set, interior of an is an itself. Just now we have said second property. Interior of A is equals to A if and only if A is open set. So as you know that this is an open set for each I, for each n. Therefore, interior of an is an. You take the intersection. What you get?
is a single term set 0. So
Zero.
it's final set.
Yesterday
No.
we have seen that. Just yesterday we have seen that intersection is singleton 0. But the thing is, interior of the intersection, we have seen that interior of this intersection is singleton 0. Yesterday we have seen. But interior of singleton 0, does it have an interior point? Does it have an interior point? No, right?
No, sir.
0 is not interior point of the singleton 0, right? Therefore, what is the interior set? Empty. Therefore, interior of these two sets, this is singleton 0 you're getting, this is an empty you are getting. Therefore, these both sets are not equal. Understand in general that interior of the intersection may not be equal to intersection of the interiors. But this result is true for only finite intersection. This result is true for only finite intersection. And similarly, interior of A union B is contained in, you can take like this. Interior of A intersection, union. Interior of A union B. This is always true. In fact, this is a proper subset. May not be equal. Can you give example? You can take this example. What is A union B? What is A union B?
1, 2, 3.
So 1, 2,
Open
3.
interval 1, 3.
1, 3. What is interior of the set?
All points, sir.
Because it's an open set.
1, 3.
1, 3. What is interior of A? 1, 2. What is interior of B?
Open interval 2, 3.
What is interior of B?
Open interval 2, 3.
2, 3. If you take the union, what you get?
Does
This
not
only gets.
related neighborhood of 2.
But the thing is, this is not same as saying that 1, 3 because it's a 2 missed. But what is this exactly precisely? Interior of A union B. Therefore, interior of A union interior of B need not be equals to interior of A union B. So the result is, true for only intersection. The result may not be true for the union, right? This is very interesting property. So these are about, intersection. These are about, interior of the set. Now, let me define the definition of limit point. You take a subset of R, because we are interested in real analysis. You take any subset of R, a point, you take any real number, just take A or X, you take any point. A point which is in R is said to be, or else you need to mention it. A point A belongs to R is said to be a limit point. In some textbook, it is cluster point. So limit point of the set is if and only if every neighborhood of a point contains at least one point of S other than the point itself. That means that is if and only if you give me any neighborhood of A which intersects S other than the point itself. This is what actually definition of the limit point. You give me any neighborhood which intersects S other than the point itself. So that is what actually definition of a limit point. Right? You collect all limit points. You collect all limit points. That is what actually derives it. That is what actually derived set of the set S. That is simply denoted by, in some books like Siemens, it is denoted by like this. In Rudin, it is denoted by A prime. What is this? Exactly derived set. So let us go for examples. Right. So let us start with a simple set 1, 2, 3, which is subset of R. Question is, does it have limit points or not? That is a question.
No,
So
sir.
Is it a limit point? You take a point which is less than 1. Is it a limit point? No, right? You give me some neighborhood. Suppose I'm going to take very small neighborhood, which is very small neighborhood. Does it contain any point other than A? Does it contain any point of S? E neighborhood
No,
lo,
sir.
E shaded region lo, 1 gani, at least 2 gani, at least 3 gani unda? Ledu. Therefore, any point less than 1 cannot be limit point. Is it a limit point? You take a point which is bigger than 3. Is it a limit point? No, right?
No,
I'm
sir.
going to choose very small neighborhood. In fact, I'm going to take a very epsilon is very less than 3. You take this neighborhood, A minus epsilon and A plus epsilon. This neighborhood does not contain any point other than point itself. It doesn't. This neighborhood does not contain any point of S. Any point of S other than the point itself. In fact, this neighborhood does not contain any point of S other than point pakka vettesandi. This neighborhood, you take any epsilon which is less than mod of A minus 3 by 3. You take the epsilon is very, very small, which is less than mod of A minus 3 by 3. This does not intersect, the set. This does not intersect the set itself other than the point itself. Therefore, the point bigger than 3 also not limit point. Is it a limit point?
No, sir.
No, right? See, if you take a very smallest neighborhood, suppose I'm going to take epsilon is 1. What is my neighborhood? What is my neighborhood around 3?
Sir, కొంచెం a limit point ని మళ్ళీ
3 minus 1. Yeah. 3 minus 1. What is definition? 3 minus 1 is 2. 3 plus 1 is 4.
4.
The thing is, does it contain any point of S other than 3? ఈ neighborhood లో 3 కాకుండా వేరే పాయింట్ ఉందా? ఈ neighborhood లో 3 కాకుండా?
No, sir. No, sir.
No. So in this neighborhood, epsilon neighborhood of 3 does not intersect S other than 3. It's an empty. In order to show that something is a limit point, what is my definition is every neighborhood of that point intersects S other than the point itself. Every neighborhood of point contains at least one point other than the point itself. ఒక పాయింట్ ఉండాలి. ఏ నైబర్హుడ్ అని తీసుకుంటే give me any neighborhood, such a big or small neighborhood, whatever neighborhood you give, that doesn't matter, but it contains at least one point of the set other than the point itself. ఆ సెట్ లో పాయింట్, ఆ పాయింట్ కాకుండా వేరే పాయింట్ ఒకటి ఉన్నా, దట్ ఇస్ ద లిమిట్ పాయింట్. సో ఇక్కడ సార్ నేను ఇక్కడ బిగ్ తీసుకుంటాను సార్, బిగ్ తీసుకుంటుండదా, నేను ఎప్సిలాన్ బిగ్గర్ దెన్ 1 తీసుకుంటాను సార్. ఎప్సిలాన్ ఫర్ ఎగ్జాంపుల్ 1.1 తీసుకుంటాను సార్. ఎప్సిలాన్ 1.1 తీసుకుంటే ఏమవుతుంది? 3 - 1.1 ఏమొస్తుంది? 3 - 1.1 ఏమొస్తుందమ్మా? 2.9.
1.9.
What is this? Yeah, 1.9. What is this? 4.1. What is this? 4.1. So, sir, in this neighborhood, 3 కాకుండా 2 ఉంది కదా, 3 కాకుండా 2 ఉంది కదా, మరి 3 లిమిట్ పాయింట్ అనొచ్చు కదా. See, what is my definition is, that is true for every epsilon. That is true for every neighborhood, every epsilon. In order to show that something is a limit point of a given set, we need to ensure that every neighborhood that around that point contains at least one point other than the point itself. If that happens, that is a limit point. Otherwise, it cannot be limit point. See, what I'm taking is, I'm going to take any epsilon is less than 1. This neighborhood, in fact, this neighborhood, you take epsilon is very small. I'm going to take epsilon is 1/2. So what you get? 3 - 1/2. 3 + 1/2. This is nothing but 7/1. 7/2 is nothing but 3.5. What is this? This is 5/2. That is 2.5. So this neighborhood 2.5 to 3.5. Does it contain any point? 3 కాకుండా ఈ నైబర్హుడ్ లో 3 కాకుండా ఈ సెట్ లో పాయింట్ 1 గానీ 2 గానీ ఇందులో ఉందా? No. Therefore 3 cannot be limit point. Similarly, ఈ పాయింట్ అయితే I'm going to take a very small neighborhood. Suppose you give me 2.5. What is my epsilon is 0.1. This is what 2.4. This is 2.6. So this neighborhood does not contain any point other than, see, what is my set? 1, 2, 3. Does this neighborhood contain any point of the set? Yes? No? Yes or no? No. Therefore, there is at least one neighborhood of 2.5 which does not contain any point of the pointers other than the point itself. Therefore, 2.5 cannot be a limit point of the set. Is the 2 is a limit point? No. I'm going to take very small neighborhood. Epsilon is 0.1. So what I'm getting is 0.9. What I'm getting is 2.1. Does it contain any point other than this? No. Similar this point? No. Similar this point? No. Therefore, similar this point? No. This does not contain any point of S other than S. Therefore, none of the points are limit point. Therefore, derived set is empty. Right? Derived set is empty. So what you observe is, you take any finite set. Not only this story is repeated for only 3 members. You give me any finite set. You give me any finite set, not only for 1, 2, 3, 4. You give me any finite set. This story is repeated. This argument is repeated. Right? So is it a limit point? No. This neighborhood, I'm providing some neighborhood. I'm providing some neighborhood which does not contain any point of the set S. Therefore, this cannot be a limit point. Is it a limit point? No. I'm going to take a very small neighborhood. In fact, epsilon is less than 1. This does not contain any point of the set S other than 1. 1 కాకుండా ఉందా? 1 ఉంది సార్. 1 నాకు అవసరం లేదు. 1 కాకుండా ఉందా? లేదు. షేడెడ్ రీజియన్ లో 1 కాకుండా ఏదైనా ఉందా? షేడెడ్ రీజియన్ లో 1 కాకుండా ఏదైనా ఉందా? లేదు. So 1 cannot be limit point. So for example, I'm going to take this point. Is it a limit point? No. I'm going to take very small such neighborhood. In fact, epsilon is, you take a point here, you take a neighborhood like this, a minus 1, 2 minus a. You take this neighborhood, you take epsilon is very minimum of a minus 1, 2 minus a. This works actually. A minus epsilon, a plus epsilon. This does not contain any point of the set S. So therefore, this point cannot be a limit point of the set S. You take this point. Is it a limit point? No. I'm going to take a very small neighborhood, teeny neighborhood, very short neighborhood. It's very small neighborhood of 2. This does not contain any point of the set S other than 2. Is it a limit point? No. Is it a limit point? No. This does not contain any. So the thing is, this result is true for any point. Therefore, what are my limit points? No real number is a limit point. Therefore, none of the points are limit point. None of the real number is a limit point of the set. Therefore, my derived set of the set is empty set. My derived set of the set is empty set. Right? So what you observe is, in a metric space, you'll see in later, in a metric space, you take any finite set in random any you finite sets. The derived sets automatically empty sets. So what is my notice is, you give me any metric space in R, not only in R, we'll see later in metric space. So every finite set has no limit points because R is a Hausdorff space, T2 space has no limit points. So once you are given a finite set, you are asked to compute what are the limit points. Definitely the empty set. Derived set is empty set. You give me any finite set that you take with respect to R, with respect to usual metric, automatically that doesn't have a limit points. Of course, this result may not be true in topological space. We'll see later in metric space. But this result is true in basically in R.
సార్ కొంచెం స్లోగా చెప్పండి సార్.
Yeah. Suppose you take this. What are the limit points? What are the limit points?
0 and 1.
Yeah.
Closed interval 0, 1.
Is it a limit point?
No.
Is it a limit point? Does it contain any point of the set S?
No, sir.
No. Is it a limit point?
Yes, sir.
Yes. You take any neighborhood, it contains at least one point. This point. So therefore, other than 0, therefore 0 is a limit point. Is it a limit point?
Yes, sir.
Yes. Is it a limit point? Yes.
Yes,
It
sir.
contains at least one point, left side to 1, left side to 1, left side to 1. 1 gaakunda left side 1 point undi. Therefore, it cannot be limit point. Is it a limit point?
No, sir.
No. So what are my derived sets?
Closed
0.
interval 0, 1.
Closed interval 0, 1.
0, 1. Right. So this is about my derived sets. This is about my derived sets. Right. Next, we'll see that a closed set. There are so many definitions for closed sets, but according to our basic analysis course, I'm going to give this definition. A set is said to be closed it contains all its limit points. That is, that it contains all its, what is this? Derived set. This contains all its limit points. If that happens, it is a closed set. Otherwise, it's not a closed set. Right? Suppose I take example. You take a finite set. Is it closed set?
No, sir.
No, sir.
What are my limit points?
Empty set.
Empty set.
Empty set is subset of every set now. Empty set is subset of every set now. Therefore, S contains all its limit point. If the limit point exists, that is inside, but no point is limit point. Therefore, automatically the result is redundant. S prime is an empty set, but empty set is subset of every set. Therefore, S contains S prime. Therefore, S is a closed set. So, what you observe? You give me any finite set, finite subset of R, has no limit points. We have seen. Hence closed set. Is it open set?
No, sir.
No.
No, sir.
Suppose you take this. Is it closed set?
No, sir.
0, not contained.
Yeah. Is 1 is a limit point. We have seen, 1 is a limit point because every neighborhood that you take, it contains at least one point which is left side to 1. 1 gaakunda left side lo at least one point undi kada neighborhood lo. So 1 is a limit point, no doubt. But 1 does not belong to S. Therefore, S is not contained. S prime not contained in S. Therefore, S does not contain all its limit points. Example, 1 is a limit point of S. 1 does not belong to S. Therefore, 1 is not in the S. Therefore, S is not a closed set. Suppose you take this. Is it closed set?
No, sir. 0 does
No,
not
sir.
contain.
No, 0.
Yeah, 0 is a limit point because
Sir.
every neighborhood that you take, it contains at least 1 point, but 0 is not inside the set. 0 is a limit point of S, we have seen, but 0 does not belong to S. Therefore, S prime is not subset of S. Therefore, S not containing all points. S does not contain all its limit points. Therefore, it's not a closed set. Is it a closed set?
Yes, sir.
Why?
No, sir.
So one is a limit point? No, right? 1 is a limit point? No, right? Is 1/2 is a limit point? No, right?
No.
Is it a limit point? No, right?
No, sir.
Is it a limit point? No, right? Is it a limit point? No, right?
Empty set closed set అవుతుంది sir.
But
Okay.
0?
Why, sir?
But 0? Yes, right? You give me any neighborhood around 0, it contains at least 1 point by Arconium property. You give me any neighborhood around 0, take any neighborhood around 0, minus epsilon plus epsilon. By Arconium property, it contains at least 1 member. Right? 1 by n is positive, minus epsilon is less than 0. Therefore, this neighborhood minus epsilon epsilon contains 1 by n other than 0. Yes or no? This 1 by n not contained in minus epsilon plus epsilon other than 0. This is true for every epsilon. Therefore, 0 is a limit point. So what are my limit points? Is it a limit point? No. So what are my limit points?
Empty set.
No, 0, 0.
Ah,
0 is a
zero.
limit point.
Only
because-
only 0. Only
But is it contained in S? Is it contained in S?
No, sir.
No, right? Therefore, it's not closed set. Not closed set. Suppose I'm going to take the example using this, take the union of 1 by n, including 0. Including 0. Now, is it closed set?
Yes, sir.
Sir, it is a close.
Yes. Because 0 is a limit point, 0 is inside the set. Therefore, S prime is contained in. Yes. What are the limit points? Only 0. So 0 is inside the set because I'm including 0. I'm including 0. Therefore, it's a closed set. Is it closed set? Yeah, use chat box. Is it closed set?
1 minute time ఏంటి సార్ చెప్పు.
Yeah, okay. చాలా ఫాస్ట్ అవుతున్నట్టుంది. ఓకే. ఏ కార్తిక్,
Not closed
Yes, sir.
set. Who does not contain.
చాట్ బాక్స్ లో పెట్టండి సార్, ట్రై చేయండి.
యూస్ చాట్ బాక్స్.
సార్ వాళ్ళ మెసేజ్ మీకు డైరెక్ట్ వస్తాయి చూడండి సార్.
కావాలంటే డెఫినేషన్ ఏంటంటే ఏ నైబర్హుడ్ అన్న తీసుకోండి. వాట్ ఆర్ మై పాయింట్స్? ఫస్ట్ లొకేట్ ద పాయింట్స్. 1 + 1 2, 1 + 1/2 3/2, 3/2 is always less than 2. Therefore, it is left side to 2. You can take 3. That means what? 4/3. So towards 1. Question is it a limit point? See, I'm going to take very small neighborhood. In fact, I'm going to take what I'm taking. You take very small teeny neighborhood, means 1/4 you can take. Suppose, for example, 1/4. My epsilon is 1/4. 2 + 1/4. 2 - 1/4. What is this? 2 + 1/4? 9/4. What is this? 2.2, right? What is 2 - 1/4? 7/4.
1.75.
1.75. 7. Question is 1.7, 2.7 మధ్య 2 కాకుండా 2 సెట్ లో ఉంది. ఓకే, పాయింట్స్ ఏంటి? 2, 3/2, 4/3, గోయింగ్ ఆన్. ఈ 2 కాకుండా ఇంతకుముందు ఎవరో క్వశ్చన్ అడిగారు చూడండి. 2 కాకుండా ఈ సెట్ లో పాయింట్ 2 కాకుండా 3/2, 4/3 ఏమైనా ఉందా అండి? ఇలా
Sir.
లేదు. కాబట్టి 2 లిమిట్ పాయింట్ కాదు. ఇదేదా కాదు, బికాజ్ ఐఎమ్ గోయింగ్ టు గివ్ వెరీ స్మాల్ నైబర్హుడ్. ది షేడెడ్ రీజియన్. ఈ షేడెడ్ రీజియన్ లో ఒక్క 2 కానీ 3/2 కానీ 4/3 కానీ ఏ పాయింట్ అని ఉందో సెట్ లో ఉంది ఈ షేడెడ్ రీజియన్ లో?
No, sir.
సో దట్ పాయింట్ ఈస్ నాట్ ఎ లిమిట్ పాయింట్. ఈస్ 3/2?
No, sir.
నో ఈ 3/2 నైబర్హుడ్ లో షేడెడ్ రీజియన్ లో 3/2 కాకుండా వేరే పాయింట్ ఉందా? లేదు
No,
రైట్.
sir.
సో 3/2 కెనాట్ బి లిమిట్ పాయింట్. 4/3
It is also same, sir.
same.
Not.
But one. So by Archimedean property, you give me any neighborhood around 1. By Archimedean property, it contains at least one member. You start with any epsilon. By Archimedean property, we find some natural number in such a way that this is always possible. But what I do?
1 is the
And-
limit point of the set.
You take 1 on both sides. So it contains at least 1 plus 1 by a naught, right? 1 plus 1 by a naught in the neighborhood of 1 other than 1 itself. This is true for any epsilon. So 1 plus 1 by a naught is my typical point other than 1, which is inside the neighborhood. ఈ 1 plus 1 by a naught ఇక్కడెక్కడో ఉంది. సో 1 plus 1 by a naught అనేది సెట్ లో మెంబరే కదా, బికాజ్ ఇట్ ఈస్ ఆఫ్ ద ఫార్మ్ 1 plus 1 by a naught కదా. సెట్ లో మెంబర్స్ ఎట్లా ఉన్నాయి? 1 plus 1 by a naught. సో 1 కాకుండా సెట్ లో 1 plus 1 by a naught ఉంది కాబట్టి 1 is a limit point. ఇదే ఇద్దాం.
No,
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 I adjust some neighborhood. I adjust some neighborhood which does not contain any point of the set. So what are my limit points?
1, sir.
Only 1. But is it inside the set?
No, sir.
No. So not close set. అర్థమైందండి? ఇంతకుముందు ఎవరు అర్థం కాలేదన్నారు?
Yes, sir.
అడగండి. ఓకే, అడగడం తప్పు కాదు, అడగండి.
సార్ ఒకసారి ఓపెన్ ఇంటర్వెల్ 0-1 చెప్పండి సార్. ఓపెన్ ఇంటర్వెల్ 0-1 లిమిట్ పాయింట్.
Right. So for example, ఈ పాయింట్ తీసుకోండి. Can you find at least one point other than this in the shaded region?
No, sir.
So is it a limit point? Is the point is a limit point?
No, sir.
Is it a limit point?
No, sir.
Find some neighborhood which is inside. Does it contain any point of the set? No, because shaded region ఎక్కడో 0 outside ఉంది. So it does not contain any point of the set. ఈ point
No, sir.
No. Is 0?
Yes, sir.
No,
Yes. Yes, right. We give me any neighborhood. This region is at least contains at least one point. This region contains at least one point x other than 0, because this is my 0 minus epsilon. This is 0 plus epsilon. Inside it contains at least one
right
point.
side.
So therefore 0 is a limit point. Is it a limit point?
Yes, sir.
Contains at least one point now other than x. Y x కాకుండా y ఉంది కదా. So therefore it's a limit point. Is it a limit point?
Yes, sir.
Yes, right. It contains at least one point, left side region, left side to 1. It contains at least one point x. Therefore it's also a limit point. Is it limit point?
No, sir.
No, right. This does not contain any point. So what are my limit points?
No, sir.
Closed interval 0.
What are my limit points? Is it inside S?
No, sir.
Because 0 is not there. 0 is not in S. Therefore it's not closed. Is it clear? Somebody asked. So suppose I'm going to take what is my derived set? Is it closed or not?
I would set a set of
Use chart box. Use chart box.
One by ఏంటి సార్ అది?
M plus
1
1 by n. M plus 1 by n.
small
Where
n.
n over n. Where n over n. See, we have stated Archimedean property in your notebook. Yes or no? I have stated, yes or no? We are given a positive real number. You are given a real number. Given a positive real number, given a real number. By Archimedean property, we find a natural number n naught such that n naught into x is bigger than y. I think lecture number 2 or 3, we can look at the next lecture number 2 or 3. I don't know. Look at the notes carefully. Given a positive real number, given a real number, we find a natural number, big natural number, as you want, as you please, in such a way that n naught into x is bigger than y. Yeah, what are my limit points? Anybody? 1, 2. Mamata, very good.
1, 2,
1
sir.
and 2.
Yeah, Pranjal, very good. Okay, good. Nice approach. Suppose you take m equals to 1, what you get? Simo set union. ఇంతకుముందే చెప్పాను 2 వేరియబుల్స్ వచ్చినప్పుడు ఎట్లా వర్క్ చేయాలో చెప్పాను. స్ప్లిట్ చేయండి అని చెప్పాను. అందుకే డైలీ లెక్చర్ పర్ఫెక్ట్ గా ఫాలో అవ్వండి. ఓకే, 2 వేరియబుల్స్ వచ్చినప్పుడు స్ప్లిట్ చేయండి, మీకు కొంచెం కంఫర్టబుల్ అయింది ప్రాబ్లం. యూ నీడ్ టు స్ప్లిట్ ద ప్రాబ్లం ఇంటూ 2 sets as you want. So first set ఏంటి చూడండి, 2. When you take n equals to 2, n equals to 1, 2, n equals to 2 means 3/2, n equals to 3 means what? 4/3 tends to 1. When you take n equals to 1, 3, n equals to 2 means 5/2, n equals to 2 means what? n equals to 1 means 3,
7/.
right? n equals to 2 means what? 5/2 means it is left side. n equals to 3 means what? 6/2. n equals to 3 means 7/2. 7/2 is nothing but what? n equals to 2 means what? 5/2. n equals 3 means what? So what I'm taking is
7/3. 7/3, sir. N equal to 3.
yeah, 7/3. 7/3 is nothing but what? What is answer? 7/3. Exact
Less
answer.
than 3. Less than 3.
Less than 3. Okay, less than 2.5 or not?
2.1.
2.1 means left side.
2.3, sir. 2.3.
Of course, 2.1. It is 2.3 also, less than 2.5. Okay, kada. So what you observe is it tends to 2 as n tends to infinity. So what you observe is that suppose you look at this point 2. Is it a limit point? Barkhanum property is possible
Yes.
because it tends to 2. It tends to 2. By the same idea, Barkhanum property, you find a big natural number 2 plus 1/0, which contains, which is inside the neighborhood. Same ఇంతకుముందు చేసాం మార్కౌట్ ప్రాపర్టీ. So the 2 is a limit point. Is 3 is a limit point?
No, sir.
No. Is 2.5 is a limit point?
No, sir.
No. 2 is a limit point. Okay. Is 3/2 is a limit point?
No, sir.
No, I can adjust some neighborhood. Shaded region లో వేరే పాయింట్ ఉండదు. Is it a limit point? No.
Sir.
No, sir.
Is 1 is a limit point? Yes.
Yes.
Because this tends to 1, because by Barkhanum property I can find at least one natural number 1 plus 1/0. Therefore 1 is a limit point. It's a limit point. 2 also a limit point. Is it a limit point? No, right?
No.
So therefore what are my limit points?
Only 1, 2.
Is it closed? Is it inside S? Is it inside S? No, right? 1 belong, 1 is in the set, but 1 does not belongs to S. So therefore it is not closed set.
Yes, sir.
But once you include the members, it is a closed set. Once you include the members, it's a closed set. Suppose you take this. Yeah. What is my derived set? Is it closed or not?
Not closed, sir.
See, you are asked to compute what is S prime. Is it closed or not? Is it open or not?
S closer, S dash is equal to 1 to 100, sir.
Is
Set
it
to-
bound at S? Is it countable? Suppose you're asked to question like this. Yeah, what is my S prime? Same strategy మీకు ఇంత ముందు చెప్పాను. ఇట్లా 2 వేరియబుల్స్ ఉన్నప్పుడు స్ప్లిట్ చేయండి. 1 plus m equals to 1 రాయండి. ఏమొస్తుంది?
1 to 99.
m equals to 2 రాయండి. m equals to 3 రాయండి. m equals to 100 రాయండి. we have seen 1 is a limit point for the set. We have seen 2 is a limit point. According to last problem, 100 is a limit point. So what are my limit points? This. Is it inside? Yes. No. Therefore not closed. Is it open?
Yes.
Is it open?
Yes.
What
Yes.
Suppose you take 2 point. Take a neighborhood. Any neighborhood. Is it inside? Yes. 2 is a
Sir,
point in
no.
the set. Yes or no? 2 is a point in the set because 1 plus 1 is equals to 2. So this uncountable set is not contained in the set because it contains so many rationals, irrationals. It's not contained in S. So therefore not open. Is it bounded?
Yes, bounded.
Is it bounded?
So please
Because-
explain once again how it is not open.
See, ఫస్ట్ క్వశ్చన్ ఏంటమ్మా, ఈ సెట్ ఇక్కడ చూడండి, నేను ఎక్కడ షేడెడ్ చేస్తున్నా అక్కడ చూడండి. ఇందులో 2 ఉంటుందా?
Sir,
First
please talk in English.
Yeah. Does it contain 1? Does it contain 2? Does it contain 2?
No, sir.
Does it contain 2? 2.
Sorry,
Oh, yes, sir. Yes, sir.
Yes. Question is, can you find a neighborhood which is inside S? Can you find a neighborhood 2 minus epsilon, 2 plus epsilon, which is inside S?
No, sir.
No, because it contains so many rationals, irrationals by density property of rational numbers. So therefore, this is not inside the set. Therefore, 2 is a point of S, okay, but 2 is not an interior point of the set S. Suppose you find at least 1 point, worst point, which is not an interior point of the set. We claim that it's not an open set. Yes or no? We find at least, what is my open set? At every point is interior point. Every point that you take in sets, that is interior point. But what you have shown is, we found at least 1 point that we called as 2. 2 is not interior point of the set S. Therefore, we claim that, we showed that 2 is not interior point, hence S is not open. Right? Question is it bounded? Yeah. See, look at the first set. What is my, the members which are sit inside, bounded by? Look at the question carefully. We have seen this type of questions in bounded. This time recalling the questions. Yeah. So what is the lower bound for this? This is 2 tends to 1, right? So what is my lower bound?
1,
1. What is this?
2,
2. What is this? Every member in the set S is bound, lying between 1 and 1 at 1. Yes or no? Every member in S,
Sir.
which is inside the set, is subset. This is bounded set. Because 1 is a lower bound, 1 at 1 is an upper bound. So we have shown that every subset of bounded is bounded. We have shown. So S is bounded. Yeah. What does it have a least member? Anybody? Does it have a least member? Least member, which I am asking.
No, sir.
No, sir.
No, sir.
So what is the infimum?
Infimum is the 1, supremum is the 1 at 1.
Yeah, does it have a least member?
no, sir.
No.
Does it have infimum? Does it have greatest member?
No, sir.
Yes,
Greatest member,
Yes,
1
sir.
at 1,
Yes,
1
sir.
at 1.
Correct.
Yes. Now my question. Is it countable?
No, sir.
Is it countable?
Yes, sir.
Manchi choose cheppandi. Is it countable? Yes. First, E set countable? Because we're counting the numbers now. We are counting 2, 3 by 2, going on. This is countable set. This also countable set. This also countable set. Therefore, countable and countable is countable set. Okay. So you should be careful. ఒక క్వశ్చన్ ఎందుకు రికాల్ కావాలని వేసాను. జస్ట్ ఓకే.
సార్ చిన్న డౌట్ సార్.
యా టెల్ మీ.
సార్ అక్కడ కింద మీరు ఇందాక ఎక్స్ప్లెయిన్ చేసింది అది ఓపెన్ టు అది 1, 2 అని రాశారు కదా, అది ఇంటర్వెల్ సార్?
యా ఇంటర్వెల్.
అది ఇంటర్వెల్ రాయొచ్చా సార్?
రాయొచ్చు. నేనేం అందుకే ఈక్వల్ రాయలేగా అమ్మా. ఈ రెండు ఈక్వల్ రాయలేదు కదా. ఎందుకు ఈ రెండు ఈక్వల్ రాయలేదు కదా. మనం బౌండెడ్ అని చెక్ చేస్తున్నాను. బౌండెడ్ అని చెక్ చేసినప్పుడు జస్ట్ సబ్స్టిట్యూట్ అని రాస్తాను. ఎస్లో ఉన్న మెంబర్స్ అని ఇందులో ఉంటాయి, బట్ ఇందులో ఉన్నాయని ఇందులో ఉండాల్సిన అవసరం లేదు. ఇలా రిలేషనల్స్ కూడా ఉంటాయి కదా ఇందులో.
అవును సార్.
ఇందులో రిలేషనల్స్. ఓకే, అందుకే సబ్సెట్ రాశాను. అందుకే ఓకేనా.
సార్
యా,
లాస్ట్ ఎగ్జాంపుల్ లో 2 లిమిట్ పాయింట్ అని ఇచ్చారు సార్, అది ఒకసారి నాకు అర్థం కాదు.
ఇక్కడ యా సేమ్ ఆర్గ్యుమెంట్. 1 లిమిట్ పాయింట్ అయినప్పుడు ఇక్కడ 2 కూడా సేమ్ ఆర్గ్యుమెంట్ ప్రాపర్టీ లిమిట్ పాయింట్ అయితే కదా ఈ సెట్ కి. సో 2 దగ్గర మీరు ఏ నైబర్ ఉన్నా తీసుకోండి. గివ్ మీ ఎనీ నైబర్ బై ఆర్గ్యుమెంట్ ప్రాపర్టీ ఫైండ్ అట్లీస్ట్ 1 మెంబర్. 2 + 1 / n0. 2 కాకుండా ఈ నైబర్హుడ్ లో అట్లీస్ట్ 1 పాయింట్ ఉంటుంది. ఈ ఎగ్జాంపుల్ కి తేడా ఏం లేదు కదా. నేను ఇక్కడ n = 1 to 100 తీసుకున్నాను అంతే. ఈ ఎగ్జాంపుల్ కు లాస్ట్ ఎగ్జాంపుల్ పెద్ద తేడా ఏం లేదు కదమ్మా. ఆర్గ్యుమెంట్ ఈ సేమ్, లాజిక్ ఈ సేమ్, ఎవ్రీథింగ్ ఈ సేమ్. బట్ ఇక్కడ ఏంటి m = 1 to 100 తీసుకున్నాను. ఇక్కడ మాత్రం ఇంతకుముందు సెట్ లో m = 1 to 2 అని తీసుకున్నాను. ఓకే
ఓకే
సార్
ఒకవేళ నేను ఇట్లా తీసుకున్నాను అనుకోండి, సేమ్ వేరియబుల్ తో తీసుకున్నాను అనుకోండి. ఇప్పుడు చెప్పండి, వాట్ ఆర్ ద లిమిట్ పాయింట్స్? యూజ్ చార్ట్ బాక్స్. What is my second point? 2 + 2 means what? 5/2. 5/2 is right side to 2. 2 + 1/2 means 5/2. What is next? 3 + 1/3. 3 + 1/3. 10/3. So 15 is always less than 20. So right side. Next 4 + 1/4.
17/4.
Yeah, what you observe? Is it a limit point?
No, sir.
Is it a limit point?
No, sir.
Is it a limit point?
No.
No.
No, sir.
Is it a limit point?
No.
No. Is it a limit point? No. Because I can adjust. Take very small epsilon. Is it a limit point? No. This is shaded region local point. Shaded region ante na epsilon very small anamata. Right? Is it a limit point? No. So no point is limit point. Is it close? Is it close set? Is it close set?
Yes, sir.
No, sir.
Is it close set? Set lo limit points ఉన్నాయండి?
Yes, sir.
No.
Yes,
It is closed.
No, limit points లేవు కాబట్టి ఆటోమేటిక్ ఏమైంది?
Closed set.
Close it.
సార్
So no limit points is always close set. Yeah, tell me.
సార్ ఇప్పుడు ఇక్కడ 2 ఉంది కదా, బై ఆర్కిమిడియన్ ప్రాపర్టీ కింద 2 + ఇట్లా 1/n0 ఇట్లా ఒక పాయింట్ ఉంది అని అనుకోవచ్చు కదా సార్?
అనుకోవచ్చు కాదండి, ప్రూవ్ చేయాలి. అక్కడ ఎందుకు ప్రూవ్ చేసామంటే 2 + 1/n converges to 2 కాబట్టి this converges to this కాబట్టి you give me any neighborhood of 2, it contains at least 1 point అని అనుకోవడానికి వీల్లేదు, ప్రూవ్ చేయాలి. need to prove it. ఇక్కడ ఏంటంటే లాస్ట్ ప్రాబ్లం లో 2 + 1 సెట్ ఉంది ఒకటి కాబట్టి you start with any neighborhood around this, we find at least 1/n, large 1/n, but 1/n is always positive, but positive 0 is always bigger than -epsilon. Once you take 2 and add 2 adding on both sides, what you observe is this condition is possible. Yes or no? ఇక్కడ 2 + 1/n అనేది మీరు కనుక తీసుకుంటే 2 + 1/n అనేది సెట్ లో ఉందని తీసుకుంటే ఈ సెట్ లో ఉందా? ఈ ఫామ్ ఉందా సెట్ లోది? ఈ 2 + 1/n0 అనేది సెట్ లో ఉంటుందా? చెప్పండి, ఎవరు అడిగారు క్వశ్చన్? 2 + 1 సెట్ లో ఉన్న ఫార్మాట్ ఏంటి? n + 1/n ఫార్మాట్ ఉండాలి.
సార్
సెట్ లో 2 + 1/n ఉంటుందా? సో నేను 2 + 1/2 తీసుకుంటాను సార్. 2 + 1/2 ఎవరు తీసుకోమంటున్నారు? నేను స్మాల్ నైబర్హుడ్ తీసుకుంటాను, వెరీ స్మాల్. 2 + 1/2 అంటే ఏంది? 5/2. 5/2 అంటే ఏంటి? 2.5. నేను ఏం తీసుకుంటానంటే ఎప్సిలాన్ ఇస్ 0.1 తీసుకుంటాను. 2.1 అయితే ఇది 1.99. ఈ నైబర్హుడ్ లో ఈ 2 + 1/2 ఉంటుందా? చెప్పండి.
ఉండదు
ఉంటదమ్మా?
సార్ తర్వాత
ఉండదు.
ఉంటుంది దాని తర్వాత
Yeah.
ఉంటుంది.
Yeah, ఆ తర్వాత ఉంటది. కాబట్టి I'm going to take very small teeny neighborhood around 2, which does not contain this.
ఇచ్చిన సెట్
Okay.
బట్టి అక్కడ మనం ఉందా లేదా అని చూసుకోవాలి.
Yeah, set is very important.
ఓకే సార్.
సో బట్ ఇంతకుముందు ఎగ్జాంపుల్ వేరీ అయినప్పుడు టూ వేరియబుల్స్ ఉన్నప్పుడు M and N వేరియబుల్స్ ఉన్నప్పుడు మాత్రం కేర్ఫుల్గా ఉండండి. సో సార్ ఏమని చెప్పాడు, N+1/n ఉంటే లేవు అని చెప్పాడు కదా. సో అప్పుడు రాంగ్ చేస్తారు. ఇట్లాంటి టూ వేరియబుల్స్ ఇచ్చినప్పుడు మాత్రం లిమిట్ పాయింట్స్ ఉంటాయి. ఓకే, బట్ డిఫరెంట్ ఒకటే వేరియబుల్ మీద డిసైడ్ చేసినప్పుడు మాత్రం ఉండవు. ఇప్పుడు చెప్పండి. యా, ఎనీవన్? Anyone use chat box? Does it have limit points? Same, very good, Naresh Kumar.
No.
No, sir.
Same
No.
strategy, right? This is my point. 2 plus 1/2. This is nothing but what? 4 plus 1/4. This is my point. 8 plus 1/8. So I'm going to take very small teeny neighborhood. Does not contain any point other than s. Is it a limit point? No. Is it a limit point? No. Is it a limit point? No. So empty is inside the set. Okay. సో మీకు వచ్చిన క్వశ్చన్ ఏంటంటే S is equals to, ఇది CSIRలో వచ్చింది క్వశ్చన్ 2015. S is equals to 1/m plus 1/n such that n belongs to m and m belongs to n. So S prime is option A 1. Cardinality of S prime is 1, means S prime contains only 1. Number of elements in limit points of the set S is only 1, 2, 3 is finite set. D is infinitely many. What is this? I'm asking. Number of elements, that means number of limit points. Number of limit points of S. Yeah, use chat box.
దిస్ ఇస్ అసైన్మెంట్ సార్, వాళ్ళు రేపు ట్రై చేయని వాళ్ళకు.
Okay, assignment.
నెక్స్ట్ క్లాస్ లో చెప్తారు. నెక్స్ట్ కంటిన్యూ చేయండి.
Okay.
Yeah.
Suppose in question at least అంటే I'm going to take this 1 plus 1/n whole power n such that n belongs to n. What are my limit points? Is it closed or not?
Yes, sir.
E. Very good. Who's that?
Chandra, sir.
Yeah. So that means it does not contain, it is no point other than E is a limit point. Why? Because 1 plus 1/n whole power n converges to E. So once it converges happens, so every neighborhood of E, we'll see later, every neighborhood of E contains at least 1 point other than this. In fact, this neighborhood contains infinitely many points of the set S. So as n tends to infinity, 1 plus 1/n whole power n converges to G. Therefore, according to the convergence, we'll see later, this neighborhood contains infinitely many points of the set A. So therefore, the only point which is E. Is it closed set? Not closed set. Is it closed set? Not closed set. So you take any subset of this, derived set is always closed set. See, in general need not be true, but we are working with real line. In fact, it's a metric space, so it is a closed set. And you take any subsets, two subsets, derived set of A union B is equals to derived set of A union derived set of B if A and B are any subsets of R. This is quite trivial. Of course, we can extend this idea to any finite union. derived set of this is nothing but union of its derived sets. A1, A2 are not any subsets of R. But if you take the intersection, it's a proper subset. Why they are proper? We have seen already. So what is my derived set of this? A, close 0, closed 1. What is my derived set of this? 1, 2. What is the union? What is the intersection? Close 0, 1, intersection with closed 1, 2. What is the intersection?
Single
1.
term.
What is the intersection of A intersection B? What is the intersection B? Is 0, 1. And this is closed 1, 2. What is
Empty.
intersection? Empty. What is the derived set? Empty. So is empty is equals to singleton 1? No. So therefore, derived set of A intersection B cannot be equals to derived set of intersection of A, derived set of A intersection derived set of B. So this is true for only finite union. This is true for intersectional. This result may not be true for equality. This result is strictly inclusion, strictly subsets. May not be equal, may not be equal. Yeah, what are the limit points? The chat box. Naresh Kumar. Yeah, good. Shivrasa Gar, very good. Mamata, good. Pranjal also very good. So therefore, what you observe is, what is this? What are the elements? Sine 1 by 1 means 1. Sin 1 by 2 is 1 by 2. Sine 1 by 3. Sine 1 by 4. Going on, going on. So this is my sets. So what you observe is that sine 1 is there. Sine 1 by 2, look at the graph of sine function. Suppose you take any, what is my n? N is a natural number. That means what? N is bigger than or equals to 1. N can be 1, n can be 2, n can be 3. So n is bigger than or equals to 1. That means 1 by n is less than or equals to 1. This is my pi by 2 exact. That means what? Pi by 2 is pi is 3.14 like this. So 1 point something 1. So whenever n 1 by n is less than or equals to 1, this sine function is increasing function, monotonically increasing function. All the numbers lying between them. So sine 1 somewhere here, sine 1 by 2, sine 1 is here, sine 1 by 2 here, decreasing, increasing function. What is that? Decreasing, sir, not increasing, a decreasing function, right? Oh, sorry. Right? So sine 1 is there, sine 1 by 2 is there, sine 1 by 3 is there, going on, it towards 0. So therefore, what do you observe? Is sine 1 by 2, sine 1 by 3, going on. With the same trick, Archimedean property, this is not a limit point because this cannot be, this cannot contain any point other than sine 1. This cannot be limit point, this cannot be limit point, this cannot be limit point, this cannot be limit point. The only 0 is a limit point because you start with any neighborhood, it contains at least 1 point by Archimedean property. So therefore, this is not way limit points. So what are my limit points? 0.
Only 0.
0. Because sine 1 is there, sine 1 by 2 is there, sine 1 by 3 is there, sine 1 by 4 is there, going on, decreasing. The function is increasing, but sine 1 by n is decreasing. Okay, so therefore, what you observe? Next. Yeah, do you have any doubts? With this, I conclude, Amma. Do you have any doubts?